Right, so my name is Jakub Rozek. I work for Red Hat. I mostly work on the SSSD. There's my Twitter account. If there's no time for questions, you can just tweet me or meet me somewhere here in the hallways. I also put the little scripts I will be showing in the demos on my GitHub, and there's also a copy of the presentation in PDF, so we can grab it, read later. This talk is about SSD, but it's not about the things that most people use when they use SSD, which is normally login as a user from Active Directory, LDAP, whatever. But it's about the parts that that are not as well known. They are very often in development, not so stable. There is few topics. I will be going quite fast, not into many details. So if you're interested in any details that I'm not going to cover, yeah, feel free to catch me later. In particular, I'll be talking about the APIs that SSD has, how can you talk to SSD from a program, why it might be a good idea to let SSD handle local users from etc password and group, why and how SSD handles smart card logins, because as we heard, PAM PKCS level is dead. And the last topic is how can SSD manage Kerberos tickets? I'm not sure even if I'm going to go to the last topic because we'll see how we are with time. Right. First topic is SSD APIs. How can you talk to SSD from your program? The first thing is why might you even want to do something like this? And the primary use case is that there are applications, quite a few of them actually, that implement some sort of an LDAP driver or LDAP connector. Typically, this is because the application wants to let people log in with their LDAP credentials or whatnot, and use data about these users. For example, the application might want to know which groups is the user member of to make some policy decisions, or the application might want to, for example, know the email address of the user to display it in the UI. This sounds easy, and it's easy to do it in some sort of trivial way. You just bind to LDAP, read the data, display it. But doing it correctly, there are a lot of details that you might not even know about the problems in the first place, much less to solve them. And some of the problems are stuff like, which server should I talk to? We already heard about Active Directory sites. If one LDAP server goes down, what does the application do? It should, in the ideal case, connect to a different server. What if the LDAP server what if the network is completely down? In that case, you might want to keep serving some data from your cache. In general, SSSD is a kind of expert in how to talk to LDAP. And it might be a good idea, instead of doing your own thing in your application, just let SSD do its thing and provide you with an API that your application uses. Of course, it's already possible to talk to SSD somehow. If you just have SSD to log in as an LDAP user, you can already run get and password your username. It will display the user. This is already talking to SSSD, right? But it's not a kind of publicly available API. In the case that I said in the get and password user, you talk to interface that is called NSS, name service switch, which inside calls the libc function get pw name, which then talks to SSD through a function that SSD provides, the NSS SSS get pw name. This is not trivial to call directly from the application. It's somehow possible you can DL open the library and DL sim the functions and then call them, but that's really awkward. And it's not really flexible. So if you call this interface, the get pw name, you only get a fixed set of attributes. You only get the username, home dir, shell, and so on. But I had the example with the email address. It's not there. So the way you can talk to SSD directly already in the versions that are released is currently through a dbus-based API. We chose dbus for several years ago because of some advantages we saw that primarily there are many language bindings for SSD for dbus. Sorry, I'm going to show some little demo that will use Python. Dbus is type safe. Dbus has types. So if you request a number, for example, the UID number, you get back a number. You don't get back a string that probably contains numbers, but maybe not. Dbus has some advanced features that might be useful, like you can get notifications which are called signals in Dbus lingo. This can be useful if you have a UI and you don't want to continuously poll SSSD for if anything changed. You just get a signal when the thing changed, you can redraw your UI. As we found out through bug reports and through feedback, not everybody likes dbus. There are disadvantages. The primary one we saw was that it requires a system bus, the message bus running, the broker. That's, for example, not available in containers. Some language bindings were not really great, and we only found out when people started trying to use the dbus API. I think the Java bindings were even unmaintained at the time where one project started to use them. But nonetheless, this is used by several projects already. Many of them are Red Hat based because we talked to the people directly, like Manage IQ, Keycloak, which I think they had a presentation earlier today, the Apache module lookup identity. Because of the problems we encountered with dbus API, we thought if maybe it might be appealing to offer some other kind of API, but we never did it. We thought about REST because that's what many people are used to. It's easy to use. And we even talked about offering the LDAP protocol over LDAP. But yeah, this is really just discussions. This talk is about SSSD doing more than LDAP client, but I'm not sure if we want to do LDAP server. Yeah. A little demo time. So I will be showing two scripts. One is written in raw Python LDAP, which Michal is maintaining, and the other is doing exactly the same thing, except it's talking to the dbus API of SSD. So let's see here. So I'm going to run the first script, which is using the raw Python bindings. And what the script does is that it finds the user who I put on the command line as an argument, and it would print their email and their group membership. Right, so boom. We know that the FOSDEM 2018 user has the email FOSDEM 2018 at FOSDEM, and he's a member of 3 groups. So I'm going to really quickly show the script. It's not ideal on this small screen, but you can see that even in the script, I have the user who I authenticate as, and I have the password of the user in the script, which is really not ideal. And there is lot of parsing and low-level LDAP stuff that probably as application developer you don't want to know. So the script is about 70 lines long, right? So now I'm going to run the script that does the same thing, except it's using the SSD API, right? It returns the same data, except I think the groups are in a different order, which is kind of expected with LDAP. So if you look at the dbus example, it's about half the size. And more importantly, I think the language is kind of more natural. So requesting the email attribute is calling a method that is called getUserAttribute. Requesting the groups is calling a method that is called getUserGroups. You really don't get down to the raw LDAP level. Right, that's all about the first part about the dbus APIs. Details. If you want more details, catch me later. The next section is about managing local users and how does SSD relate to users and groups in the HC files. Again, why do you might want to do this at all? One of the reasons is faster access to the files that are the users that are stored in the files on the disk. Traditionally, you could use NSCD, which is a name service caching daemon that comes from libc. But what we found out through the way of bug reports from users is that people who used NSCD because they wanted to have faster access to users on the disk, but they also used SSSD because of some remote users in LDAP. they were complaining about these two caching mechanisms not really playing well together. Right? And SSD sits kind of in front of SSD, and the caching was really unpredictable. I showed the APIs previously. Another reason why we might want to use SSD for local users is that the APIs that I showed might actually be used also for local users if SSD is serving them in the first place. And then we could have a nice API for user, not management, but reading user information on Linux for all kinds of users, be it remote or local. SSD uses a database to store the user data. Database comes from Samba, it's called LDAP. And in the database, it's possible to store additional attributes. So we were thinking about storing stuff like maybe the keyboard layout or your preferred language in the database. And then this information could be, through the dbus API, offered to whoever is interested in them, desktop environment, for example. And the last reason is smart cards for local users. SSD, in order to authenticate some users, it must first know about them. Therefore, SSD must be serving the local users. I'll have a separate section on the smart cards later with the demo. So this is already kind of underway in Fedora. If you're running Fedora, since the Fedora 26 version, SSD is running by default on all installations, and it is mirroring the contents of etc password and etc group. We have a iNotify watch that kind of updates the database and drops all caches if anything changes. The way the caching works is that if there is a request coming from application like LSL wants to convert the number to name, the request goes first to SSD. The first request goes to the daemon, which is a little slow, but then the daemon, as part of the reply, puts the reply into a memory mapped cache. So any subsequent request would not even hit the daemon. It would just be in the NSS module, which is loaded into the memory space of whoever is calling it. As I said, the reason we're doing this is that this way caching for local users interoperates easily with whoever with SSD that might also be running on the same machine and serving users from LDAP. Disadvantage: SSD is bigger, fatter, more complex than an SSD. If you just care about local users and nothing else, you might just be happy with an SSD. There's nothing wrong about it. And the other disadvantage is that this actually, in order for this to work, we had to revert the order of the NSSwitch.conf modules. So traditionally, files was always first in the NSSwitch.conf database. In Fedora since 26, we reversed it, so SSD comes first. This does not require SSD to be running at all. It doesn't require SSD to be installed. If the SSS module finds out that the daemon is not running, it will just gracefully fall back. So, if SSD is not running and you want to access root, it would work. So this is very much work in progress. The next thing we want to do is improve the smart card integration. You'll see later why it is currently very user-unfriendly. We want to make it possible to extend the local database with more attributes like the keyboard layout or whatnot that I talked about. Currently, it is somewhat possible. We have a command line tool that is called SSS override, but currently it only allows you to add public certificate to for the smart card authentication. But right now, there's no general API or command line tool. There were some people who wanted us to extend the dbus API to allow write modifications. This, I think, came from Cockpit. So if you had some kind of create user method on the dbus API, it would call to lib user and create the user locally. And as I said, we would like to have a unified API for providing information about local and remote users. So what we're thinking about is to merge with this project from FreeDesktop's account service and kind of implement or offer the same API from SSD. Hopefully this would happen this year, but this is kind of project that we've been working on for a long time. We have never had the time. That was local users. The next section is smart cards with SSD for primarily for local users. So I'm not a smart card expert by any stretch. The previous Jakub who had a talk right before me there's a link to his talk. He also gave a similar talk on a different conference last week or 2 weeks ago. The second link is to a recording of his talk. If you haven't seen it, you can. I even didn't write this part of SSD. I really literally learned it as I was preparing this talk, but I can illustrate how it works. So traditionally, if you wanted to use smart cards and log in as a local user with smart card, you would use PAM PKCLS11. It has a lot of features. It was super stable, but there's also no development. I think the primary developer abandoned the project and nobody else stepped up. It even doesn't build against recent OpenSSL versions, and for that reason, it was dropped for Fedora. So currently in Fedora, there's no way to authenticate, I think, as a local user within the smart card. Kind of in parallel to that, SSD was gaining support for smart card users, which wasn't at first meant for local users. It was meant for remote users. The primary use case was free IPA and trust with Active Directory. The way it works on a very, very high level is that the certificate is stored in the directory. If a smart card is inserted, then the SSD runs a search against and tries to find based on the certificate, tries to match the user, and then either does a PK in it, so Kerberos authentication with a key, or does kind of a local authentication and just on that machine. It's functional for local users. I'm going to show you. I would not call it usable by anyway because it requires a bit of manual configuration. So first, SSD must be serving the local users, which is already default in Fedora, but I think not elsewhere. The smart card doesn't have to be a real smart card. It can be anything that implements the PKCLS11 interface. I'm going to use a YubiKey for my demo. You need to load the certificate into the user database with the SSS override tool. I'm not going to show this because I don't have the time. And most importantly, the authentication, even though it's a local user, must be handled by PAM SSS, not PAM Unix. We haven't really thought through how to change the PAM stack in Fedora to make this possible in kind of generic way, but I'll show a demo. This is something we will be working for Fedora 29 to make it more user-friendly and everything should work by default, but we are not there yet. Right, demo time. So this is a VM. I wrote a simple program that just runs a PAM conversation and authenticates a user. So first I'm going to authenticate a user called test. Right, so hopefully I can write the password down. Okay, so the user was authenticated. If we look at the journal, the first line here is from audit, and it says that PAM authentication was successful, and the grantor, the module that allowed the authentication, was PAM Unix. So this is what you do normally, authentication against its shadow. So now I'm going to run second authentication, and as you can see, this time I was prompted for not for password, but for PIN, and I don't remember the PIN. I have it here in the. This is not secure. Don't do this, except if you are demoing something on FOSDEM.
Good that you mentioned that.
7231. And I was authenticated, so PAM authenticate returns success, right? And I'm going to show the journal again, and there is user auth, right? So user was authenticated, and it was authenticated by PAM SSS. And the user I was using was called local smart card test. And if we look into etc shadow, you can see that there's something missing, right? There is no hashed password for this user. So I couldn't have authenticated against etc password with a at shadow with a password, even if I wanted to. If we look at the first user I was using, right? There's a password. Okay, how much time do I have? A few more?
We have like 12 minutes.
Good. So I'm going to run the last section, which is why it might make sense to let SSD handle our Kerberos tickets. So I will not go into details on Kerberos, but for the purpose of this, let's just say that if you authenticate against the Kerberos KDC, you get back a ticket. It's a blob of data, and this blob of data must be stored somewhere. That somewhere is called credential cache in Kerberos speak. There are several options. The easiest one is that you can just write that blob into a file. You can write it into a directory that can subsequently contain multiple credential caches for multiple Kerberos principles. You can put it into Kerberos keyring, which is the default on Fedora and in RHEL, or you can use KCM. This is what this part of talk is about. I should mention that KCM is not my idea, it's not our team's idea, it comes from the Heimdall Kerberos distribution. I looked at the Git logs as I was preparing the talk, and the first commits for the KCM part of Heimdall are more than 10 years old. The idea behind the KCM credential cache is that it's not, unlike the files, which you just put a blob right into the file, right? That's it. Here, the credentials are handled by a daemon. And the advantage of this is that the daemon, because it's kind of active component, it can then do things with a credential cache that, like, I will get to the details later, but there's more functionality you get out of this. If you will read some documentation about KCM, the terminology is that the KCM daemon that is managing the credentials is called a KCM server. The tools whoever is talking to the KCM daemon, typically it's some command line tools like kinit, or an application that uses libcurl5 is referred to as a client. Even though there is a server and client, there's no network communication. It's all local communication over a Unix socket. At the moment, Heimdall implements the KCM server. MIT doesn't. MIT only implements the client part. So MIT implements the support for this KCM protocol over the Unix socket for the tools, but not the server. You can mix and match them, and that's how I was testing our KCM implementation. I was using KCM server from Heimdall against kinit from MIT, and it worked. I'm not sure if it worked in some production environment, but it worked for me. So why would you want to do this? As I said, the KCM daemon is stateful, so we can do things like renew the Kerberos credentials. Kerberos, the credentials you get back in the C cache have a limited time, but sometimes that time is not enough. For example, if you're running some batch job on some cluster, that job might take longer than the lifetime of the credentials. What daemon like KCM can do is renew the credentials for some time. Again, notifications, that's one of the things we want to do. If the credentials are acquired, about to expire, have been renewed, you can send a notification. We would like to use the dbus API that I was talking about earlier. And I think GNOME was already interested in using these notifications for this environment. You can also, you can also do things like if the user who was using these credentials logs out, you can get a notification from login D and wipe the credentials out. The credentials are also not written to the disk, which might be beneficial for sharing the credentials between two processes, because if they are on disk, they need to be in a predictable location, and this might not be super secure. What we also wanted to do is this way make Kerberos usable for containerized environments. the way we thought this would work out is that because the KCM server has a Unix socket, then you can run a KCM server in a container, and then if you have other containers that are maybe running some applications, those containers can bind mount the Unix socket of the KCM server, and this way you can share the credentials only between selected containers, unlike, for example, the keyring, kernel keyring, which is shared between everyone. What we found out is that nobody's really interested in using Kerberos with containers for various reasons. I think mostly. Really? Awesome.
We can talk afterwards.
Okay. So one person only is interested in using Kerberos with containers. Cool. So the implementation of the KCM server in SSD is called SSD KCM. It reuses a lot of SSD code, which is one of the reasons it lives in the SSD code base, but it doesn't need the rest of SSD. You don't need to have SSD serve any users, even local or remote. You can just system control enable the KCM socket, and then it works. We're also planning to use some private APIs of SSD. Again, another reason why this is a project inside the SSD umbrella for features like notifications and so on. KCM is the default Kerberos C cache since Fedora 27. There are bugs though. Some are still open. I didn't really have that much time to look into them, but I will in the next couple of weeks. The current version of what we have in Fedora is just equivalent to the other C cache types. We don't really have implemented the features like the renewals notifications and this. But we are going to. It's on my to-do list for Fedora 29. If you want to learn more about KCM, there is a design page on the SSD wiki, and there is a link to the MIT Kerberos wiki page, which describes much more details about, for example, the protocol that the libraries use. That's all. Thank you. Do you have any questions?
I would like to ask about the caching of SSD in the sense that how often is generated, and in case, for instance, the server goes down and the loss connection with the identity management, how long will it be valid?
The cache?
Yes.
As long as SSD stays offline. So if SSD is offline, it never removes anything from the cache. It will just serve cache data. And if you log in with the cached credentials, in that case, you don't get a ticket. So it's just local authentication. And then, for example, repeat the question, how long is SSD cache valid? So one interesting case there might be that SSD is offline. At that time, the administrator removes, for example, remove some of your group memberships, right? The next authentication that would happen online would refresh the cache data, but as long as you can't reach the server, the cache just stays the same.
The system is online? How often is generated?
It's configurable, and there are two answers to this. One is that for just if you run something like get and password or ID from the command line, there is, I think, 45 minutes or 30 minutes, something like this. But if you log in, as Volker already said before, login is the only time where you can get precise group information. At that time, we never use the cache. We always process the reply from the server.
I have a question that sort of relates to that in terms of debugging SSSD and PAM and knowing where a problem is and knowing when a cache has expired or when SSSD probably has issues contacting the server. What are the typical ways of debugging SSSD?
Enable debug logs. Look there. So what are the typical ways of debugging problems like in order to learn that SSD, for example, is offline because it cannot contact the remote server?
Just as a random example, but it could be like any other problem.
So we just talked about this with Fabiano over lunch, that our debugging is very suboptimal. And currently, you need to enable the debug level in all the SSD conf sections and just look there. We have on the SSD wiki, we have a troubleshooting guide which might help you. I'm not sure if you saw that. And what we did in the last 2 or 3 releases, we have a command line tool that is called SSS control. And that tool has subcommands. One of that subcommands is, I think, domain status or domain info. That would show you domain is offline. Another command there is something like user status or user show. I don't remember the commands precisely. And this would show you, for example, when was the last time that the user was refreshed from LDAP. So this tool maybe can be used. Yeah.
Do SSSD support transitive trust relationships?
No, only WinBound can do this. Because, repeat the question. Does SSSD support transitive trust? No. Somewhere in the backlog, and maybe it is something that Andreas might work on someday, no? But if I understand it correctly, and maybe Volker can help me, but I think, so SSSD, if it's...
We need better WinBound integration with SSSD.
Yes, yes.
We need these phone calls again.
Yes. So if SSSD is joined to an Active Directory domain, it has credentials only from that domain, a key tab that represents the machine account. And time is up, I will just finish this one answer. And that key tab cannot be used to authenticate or to authenticate you against directory servers in another forest. I think WinBound does this by the the Windows RPC calls.
We don't. We just ask our domain controller for authentication.
Okay.
Yes, but we do that over network.
Right.
Okay. And SSD only uses LDAP and Kerberos and
Yeah.
Yeah, that's not possible.
Yeah.
yeah. There were some phone calls we had maybe 1-2 years ago where we talked about splitting some parts of WinBound and making them reusable, but nobody did the work. Yeah.
We need to revise that.
Okay.
User secure. Secure socket layers.
Uh,
Doesn't help.
Sorry, guys.
time is up. Thank you very much for listening.